become more familiar, so they can help build the protocol and just build the tooling around it. And then, yeah, the second one is so that we have people that are working on this full time, or not full time, but like part time, and making sure that the right tooling is there for the users. The idea is to set up a guild where potentially we can build into smart contracts somewhat of a reputation system and a way for users to work their way up to become someone with protocol engineering. That hasn't been fleshed out yet. This is all in ideation phase. I think the idea of this initial call is to sort of do a walkthrough, engage interest, and see if we cannot break off into maybe smaller groups and work on particular pieces of the tooling. And then I think the creation of the smart contracts and the actual guild will come a little bit later on as we sort of go through the process and find out how it works and what we need.
Yeah, cool. I think that's a good way to put it. So one thing that I want to suggest to folks here is that the idea of the guild is that we should have faucets that just pay out automatically daily or weekly to members of the guild. And it's okay if you're just reading stuff about Rust or whatever technologies the guild's interested in. So you'll get paid for showing up to a call like this, an instructional call. You'll get paid for reading in your own time about Rust, and we'll just, we're going to assume honesty on a lot of this case. But, and then you gradually work your way up into doing different things. There'll be greater payments for different levels of contribution, but generally there's always a faucet on for anybody who's interested in just paying attention to what's going on in technical stuff. But what we're talking about here is a sort of an intermediary part of the faucet, I think, which is, okay, people who have some time, very, very part-time, ability to look at code that's already been written. So we're not asking people to develop new components, not asking people to do new modules or even new functions, but just people that can go into code that's already been written, usually written quite, quickly and, in best efforts, and improve it, And so anybody that has some software skills, you will be able to see where things are done in sort of a less clean way, and just clean things up a little bit. So I think that's sort of where we are here with sort of an intermediary sort of level of the faucet. So that's what I would suggest, for now. So it's like, okay, right now there are two levels of the faucet. One is you're just showing up and learning stuff, and this is what we're doing here today. People get paid, no questions asked. And then there's the intermediary step, which is, okay, you clean something up, and it could be just as easy as formatting the Rust code, I'll show you the automatic, of course, tools that'll do this for you. And then there are other things that you can do, like refactor a certain part of it. I think that's sort of what we want to do, is just make it like low friction, the easiest and simplest thing that we can possibly ask of people to do, and then you're in the faucet and you're getting points from there. And right now we'll just do the faucet manually, so we'll just commit to paying it out every week. But in the next couple weeks, we'll be able to automate that. So I don't think it's a big project to actually get a faucet working for this. So I'll stop here. I said a lot of things. How's everybody feeling about that?
Very exciting.
Sounds good.
Yep, I feel the same. So I have some Python scripting experience, a bit of Node.js and JavaScript and TypeScript. So learning Rust shouldn't be too much of a hassle. So just want to learn it the right way. and up to a, let's say, community standards.
Yeah, awesome. Like, here's what I'll say to everybody here now. So we're starting the sort of construction call now. I mean, I come from interpreted languages as well, so I did a lot of stuff in Node.js, mostly. I've done stuff in Python in the past, but but I come from that world. And so when I first started we were working on the Libra stuff. This is 3 years ago. I mean, I had no experience with Rust. I'd done some stuff with type safety, with Java and TypeScript, but I first looked at Rust, at the Libra code and the Rust, and the size of the project is just incredible. Like the amount of code, I think, at the time it was, I think, the largest Rust project, maybe only second, the largest Rust repo, let's say. It was certainly the largest Rust repo. It might still be. So it was just incredibly big. And then when I started looking into the actual Rust code, I said to myself, I've never learned this. It's just not possible for me to learn Rust, I'm gonna have to move into like the more of a engineering management capacity and like get people to work on stuff. It's just not possible. But you spend enough time on it, you pick it up, and I don't know I'll be honest with everyone here. I don't know. I'm not a great engineer, and I certainly am not a great Rust engineer, and I haven't got into sort of I haven't gotten to the more advanced things, advanced aspects of Rust that I'd like to even, but it doesn't mean that I can't be productive and do stuff. And so I think that's a sort of an invitation to everyone here, which is, okay, so you've done JavaScript in the past, you'll be able to be productive here on Rust stuff and help fix the tools that you're using. So that's sort of my optimistic take on it. Any thoughts, comments?
Yeah, guys, I think it's a very great idea because I actually started looking at Rust when I joined OL. So at first, I'm not gonna lie, like I got a headache like jumping into the repo. So like OD sent some materials and resources for me to kind of look over Rust. So like it looked so like okay. Like I started understanding it, and I could understand a little bit of what was going on. I think I just kind of backslided a little bit because of maybe other projects and stuff. I think this initiative is very great. Like I really like the initiative because it will at least keep me accountable.
I've got a bunch of Rust stuff in here, but I'm just gonna do a thing. This is a high wire act here, but so I'm gonna make a new. Sorry.
Sorry to interrupt, Podi. Just a heads up, I'm taking notes, so I'll post notes after.
Awesome, thanks, Wade. This here is going to create a new folder. Good, okay, that worked. So I'm going to go into the hello package, and this just does a bunch of your hello world sort of stuff in Rust. And so the big things, the two main things that you'll see in your Rust project. Let me open that folder. Oh, of course. Okay. What shall we do here? Here we go. So here's the hello project. And so I've got a couple things to look at. Well, one of them is the cargo, and it should update the target folder here. Okay. Anyway, it should be somewhere in here, the released version built. But that's effectively everything that's going on in a program in Rust. So I'm not going to get too deep into it today. There are lots of, and we'll point you to some other tutorials on Rust to get you started. But I just wanted to give people sort of just message me in the background here if you're too embarrassed to ask in front of everybody else. Write me, but like there are no silly questions here. I mean, nobody's seen Rust before, so. Should I walk through anything else again here, or should I? Because the next thing I'll do is I'll now walk through the structure of our Libra project. Nope. Cool. So let's go to our Libra project. So we've got a bunch of, effectively each one of these folders here are different subsystems. Now, these would ordinarily, so this is a mono repo structure. So we've got effectively what could be different, effectively software products in each of these folders. So let's start with sort of the more maybe familiar things for everyone. I'm wondering where do I start from this? Okay, I'll back up for a second. We've added one folder here in the mono repo, which is the OL folder here. And in here, we've got a bunch of our tools. And so this is the stuff that I think most of you guys, us in this group here of our tool scrubbers are going to be spending time on the original code OL produced. So I'll just go through a few of them quickly, but we have the transaction sending tool, TXS. We've got the tower tool that you guys are familiar with from being a validator. So we do the delay tower. Onboarding tool to create accounts and onboard, e-management. We've got a number of integration tests that we run. These are just some scripts. And the big one is our CLI. So CLI is the OL commands that we use often in different places. And it has a bunch of different things. All of these are command line tools that we have. So all of these programs that we've written, you interact with from the command line. So most of us are going to be spending time here on the OL stuff. The rest of it mostly is stuff. This is stuff that we took from Facebook, right? And we have many OL changes within a number of these modules, and we don't have to really get into those. But let me just walk through a little bit of the structure. We're not going to be spending much time outside of the OL folder for the work we're doing here, but it's just good, I think, for folks to have a familiarity of what the entire repo is doing. So how should I do this? I might take it from, maybe I'll take advantage of this and it'll just be maybe good orienting for people on how blockchains work. First thing is storage. So DM, Libra have a type of storage architecture called, which uses a Jellyfish Merkle database approach. So, if I can say this simply, it's a database tree structure based on Merkle trees. And Jellyfish is a way of using sparse Merkle trees to create a more efficient search on trees. This is how I understand. Somebody correct me. And so we got a bunch of things related to storage in here, and so the storage is like subsystem in DM, and then we've got a bunch of modules within that storage system. It's like the storage interface. How do we connect to a storage instance, effectively a storage server? and ask the storage to save things and update things. So we don't have to spend too much time here, but basically what the storage is the storage service subsystem is called DMDB. So that's the storage stuff. That's all in there. And you can see it's an enormous project, because like you just open up the storage part and it's just like project after project after project. Each one of them has its own sort of source and cargo toml in each one of these things. So just the storage folder here would ordinarily be its own GitHub repo with a bunch of different modules on it. So that's storage, and that's a huge module, but like, look at everything else we still have to make a blockchain. So I'm not going to do this alphabetic. I'm going to go, okay, so once we have storage, we need to have something to apply to storage, and that's basically execution of the state machine, right? So when we have the execution of the state machine, we've got a few different things that we're doing, but basically we have this subsystem called the executor. And we won't have to get into it too much, but we're executing state transitions that we're giving to the executor. The executor then is basically importing stuff that's in the language folder here. And this is an enormous one here as well, but it needs the executor needs a couple of things. It needs a virtual machine. So the DM virtual machine is in here. Again, it's a big file. The DM virtual machine is a bytecode virtual machine that uses compiled Move language, and that's the new language that Facebook invented. There's a bunch of stuff related to Move in here. And that's all so that we can have basically execution of smart contracts and state transitions. So that's where are we? Executor. Execution, which then sends us to storage. And in a blockchain, once we have sort of the execution of a smart contract and we package it up as a block, we then want to share it with other nodes on the network. And so for that, we have state synchronization. And we've got a bunch of stuff here related to how we evaluate if state synchronization is happening. And then the state synchronization stuff is imports the network stuff. And so we've got how do we connect to another node, and how do we do handshakes and authenticate with other nodes. That's one thing. I'm trying to cover the most important things. And then another thing related to, and then we have networking, right? And so all of this, then, part of the network is we need clients to be able to connect to the network. So we need the clients to be able to connect to a node, so that's the client stuff here. And then we have one thing I skipped here is mempool. That's a bit in the weeds here, but basically how do transactions from a client get onto the chain? Well, they first, after a node accepts it, it goes onto the mempool. So basically the task queue of transactions that need to get executed, which then go through the virtual machine, sits in language, which then hits the storage layer. Anyway, I'm going through this really fast, but just to show there's a lot of interactions between, a lot of imports in between these different folders, and that's, and it is a very large, a lot of these things are very sophisticated, very large project for us. So I don't expect anybody, I'll say this differently, in the actual Facebook team, there were people that never left their individual sort of modules here, their folders. They never looked into never did any work, committed any work outside their given place. So like, if you guys are going through this and saying, well, it's overwhelming, yes, it is overwhelming. There's no way that you can actually know everything about all of these subsystems, one person. So anyway, I'll stop here. I was speaking very fast through all this. Any questions, anything folks are interested in?
I was just wondering how the dependencies work. So is it just that you create this cargo toml and then it has like the dependencies? So just like the project or this, what is it, this package JSON for the JavaScript, so where you put the dependencies? So for
Yeah.
Okay.
Cool.
And
Well,
then,
let's step. I'll work through the. Yes, I'll give a little walkthrough on dependencies in a second. Yeah.
all
Good.
right, nice.
What? Anything else?
And then I was wondering, when you are like, how does this when you build, you are building the whole project, which is like also downloading dependencies for each submodule and building them. I'm still not getting the picture of, because this is like a bigger project, so I'm not sure how, when we do this make bins or whatever, maybe what does it do, how we move from the source to binaries or to some, what are the artifacts that we come out with when building a Rust project.
Cool. All right. Yes. So let's do that next. Let's see. Misko, CJ, you've been wanting to say something, I think.
Yeah,
Yes, I
guess
just
I-
wanted to.
go ahead.
Yeah, I wanted to maybe ask if you could elaborate on the clients. Like, does the clients mean like the user who is trying to use the network, or like those running the code?
Oh, sorry, I couldn't quite hear the end of that. You broke up into some static. You're wondering about client.
Yeah, like I was asking whether the clients are like the users, or are they the people running the node, like validators or something?
Yeah, okay, that's a good question. I skipped over that. So the actual nodes, the validator nodes themselves, are done. Is this folder here? So these are GM node runs validator nodes as well as full nodes. This package here. The client tools are basically, I think, and in this case, it's just this is. There isn't a, so there are a number of binaries that are possible, a number of programs that are possible using this client library here. That just basically says, well, how do you connect to a validator node from a program, either from the command line, importing it to your program. That's what the client stuff is. So when I say client, I'll say this very explicitly, I don't mean an interface. I don't mean like the web interface or the GUI program like Carpe. When I say client, I mean a connection from an individual computer, a program that connects from an individual computer into a full node. Does that help, or is that confusing?
Yeah, that's clear.
Okay. Yeah, I'm picking up some static from your microphone, so you just might want to check your microphone's connection. Misko, what's up?
Yeah, so my question was pretty similar. You know, this is validator full node only code or client only, along with, you know, is there like, it looks like there's an SDK package, and how does, if that SDK package is used for creating clients, how is it used? How does that all work together? But since everything is in the repo together, at least for me, compartmentalizing you know, this is validator and full node stuff. This is client, Carpe uses this. Carpe wouldn't use the validator for full node code. That would be helpful for me.
Yeah, great. So let me walk through. Let me see if I can hit two birds with one stone and walk through some of this. DM and Libre just generally didn't create a lot of client code. They created like a little dummy, not dummy, little. It's actually it was very well done, but I've been calling it a toy client that we could use in the. Actually, they put it outside of the client code. I think it's in test suite. Yeah, I think it might have been here, but most everything in here, to answer your question, is validator and full node code. The only, and then the client stuff is basically OL had to write a lot of the client stuff because it just didn't make sense. So tools, and I'll get into and show like some client example things, but like mainly like the TXS tool that we wrote here in OL is a client. And it instantiates a client very briefly, a client connection to a full node to send a transaction over. You sign and send a transaction over, and then that's it. So that's the simplest client tool that we have, and we had to write. The tower that we have, so the tower tool, that is also a client. What it does is it does the mining, right? Mining for OL, and then creates a client connection briefly, and then sends it to a full node. So I think that might be sort of the best way to think about it. Most everything out here in DM space is all for full nodes and validators. And then in a lot of the client stuff we had to write. So the Carpe stuff, actually Carpe is in a different repo altogether. We didn't put it underneath the OL folder here, just too much to keep track of. But Carpe imports stuff from here. It imports TXS, because this TXS, this is something that's important to say for people who come from Java and other things. In Rust, your project, your module can be a binary that you compile and you run, but you can also import from a project that is a binary. It's intended to be a program. So you don't need to necessarily have a separation between what's a library and what's a binary. You can have something that's just a library project, that's just a crate that you import into other things. But if you have something that's a binary and that has a main, you can easily have your other program import from that. So maybe now I'll go into what Noor was asking for of how do dependencies work. But Misko, was that helpful? Did that answer some of what you were interested in?
Yeah, I think that got most of it. I guess the one other question is, on the DM website, they have an SDK section where they do have SDKs for various languages, Java, Go, and Python, and then surprisingly they have coming soon Rust. So it's not there yet, but we do see a SDK package in there, and so is that SDK package expected to be used for, let's say, clients, and is that maybe why they haven't done as much client work?
That surprised me. They said that the Rust SDK is coming soon, because I actually haven't used any of the other SDK stuff. So when we say so I think what SDK means in here, and mind you, we're using a very old version of DM in this sort of this code base that's here. In the coming weeks, we're moving to basically what's the end of line commit from Diem after Diem was basically sold to Silverbank, from Facebook to Silverbank, and Aptos also then forked from there. So we're now going to catch up to the end of line code in the next coming weeks, and there are new SDK things in there. So I am reluctant to say much about the SDK stuff here, but what I will say is this will be a more advanced thing, but in the DM code, we have this thing called we have this Rust library called Transaction Builder that will, it's basically the SDK that you're looking for most transactions, which, you know, you need to construct a transaction, how to move code. So this is advanced for, don't know that, I think people who are interested in this stuff, we can regroup about it. But this is how you would, there are Rust tools for creating transactions and signing those transactions. We've basically wrapped all of that Rust SDK stuff in our TXS library, basically, that we've created. And we can walk through how that works. But yeah, so that's what I would say. And the SDK stuff for other languages are just, as I understand them, they basically just format transactions for you in the wrappers for formatting the transactions that you need from taking the move bytecode. So you need to actually take the move bytecode and insert arguments into that, and then you need to take the move code, insert arguments into that, and then create a binary from that, and then sign it, and then create a client connection to send that over. And so the different SDKs, they do that in each of your languages, but it's always the same, basically the same thing. It's, okay, what's the move code that you want to execute? What are the arguments you're going to pass into it? And so you do that in Python. You're going to write that off in Python. And then, do signing, and I think the signing is probably language native, possibly, or it might just fall into Rust stuff. I'm probably confusing you all and some things. So I'm actually not sure on the status of this SDK stuff, to what extent it leverages compiled Rust tools, or how much does it do everything natively, like signing a binary transaction? How much of that is using native Python, native Node tools for cryptography and such? So that's something I just haven't spent any time, because I stay in Rust. I do everything in Rust. But is that helpful? I think I probably didn't answer everything you're looking for.
Yeah, no, that makes sense. Cool. But I agree, it's surprising that they say coming soon for Rust.
Yeah, I'm thinking they're probably meaning higher level tools that you don't have to like. Yeah, I think they probably need higher level tools because, yeah, most people. Because then we just import stuff that we need directly into our client tools here without needing an actual SDK. We want to talk about how do dependencies and imports work. So I'll do the simple. Let's go to the hello world briefly. And what could we possibly do here? I'm interested in showing how people import crates. In Rust, a packaged library, so to speak. So like in Ruby, it would be gem. In Python, it would be a, what do they call it? What are they called? Somebody help me. Eggs?
Yeah, it's wheels.
Wheels, yeah, that's right. And in Node, it's npm, just npm packages. I don't think there's something word for. In in Rust and in Cargo, they're called crates. So, I mean, again, you'll find some other tools for this, but here, I'm just gonna import something. Oh, you guys probably can't see my browser screen, but I'm gonna take something here, a crate that I want, which is like the time crate. And so I'm gonna import it into my Cargo. And then, on this I'm gonna be using some of the magic, I think, from Rust Analyzer. Okay, cool. So this is why the Rust Analyzer tool is important, because it'll give you autocomplete on stuff. So you can see that I've got a bunch of stuff going on here at the bottom left of my screen, where Rust Analyzer is running and indexing just from me dropping in this crate into the dependency. It's quite nice. So I'm getting some autocomplete here from the time crate. I want to use the now UTC. Do I need anything? No, it doesn't give me anything. So I'm going to say let t equal time. I'm not sure if this is something we're going to talk about with Rust with types, but I'm not sure if this type that is returned from UTC is printable. I can easily check if it's printable, or things that aren't really designed to be printed. You have this debug macro in Rust. So we'll get into this in a minute, but these things with exclamation points in here are macros. You don't see macros in interpreted languages. As far as I know, I don't remember seeing some in Node. But you want to, this macro is sort of a meta programming language for executing things. So it's not actually a function. It's just, there's a function running in the background here based on sort of a string of tokens that go into, maybe for another day. But so now what have I done? I've imported the time crate in here, and I am just doing a simple function that it doesn't take any arguments. And it's giving me this type TM. And now I'm going to do what's called a debug print, because I don't actually know if it's formatted correctly, to see what that T is. And then later on, we'll explain why we're using this ampersand in here. But let's run this. Let's see if this works. So, because that's not how it's spelled. DBG. Okay. Okay, good. So it worked. So I got my hello world print, and I've got this object. I've got this data structure that came back from the TM, from this TM type. Wondering if, now this is just for my curiosity. I'm actually going to see if print line works just as well. Sometimes it does, it doesn't. So. Yeah, see, you get this error. TM cannot be formatted with the default formatter. There's a longer explanation for why this is, but it's just basically that this TM type, what can I navigate to? Anyway, this TM type, it doesn't have a way of formatting the actual thing into a string. So debug is your friend is I guess what I want to say to all of you guys. Use debugs, find out what is actually in the data structure. So I'll stop here. I don't want to go too much deeper on how imports and dependencies work. Noor, did that help? Do I have any other questions?
Yes, thank you. No questions.
Yeah, I just have one question about the import. So you imported into dependencies, but like you're not importing it above like main, like you would in say like a node example. But I have seen that done in other packages in Rust. Why don't you need to import time above so we know that it's in like the module? Is it because it's in main and not a submodule?
Yeah, pretty much. Everything from the everything at the lowest at the root can be imported into main. So I skipped over that part. But let's actually go into like some real code that we have in OL. Let's see. Let's do TXS because we've been asked about how to send transactions. Demo. Okay, so we have this demo transaction here. So let me just give some folks some more background here. So TXS, what does it do? It's a command line program that we want to that we use to send a transaction to the network. So it needs to do a couple things. It needs to connect to a node, and it needs to take a what's called a transaction script in DM. So it's a transaction that you want to execute. It needs to sign it with your private key. So you're gonna sign this transaction, and then make a connection to the full node, and then send that over to the blockchain. And then wait. Actually, the other point is you need to wait. Basically, by polling, so you ask the full node every 5 seconds or so, hey, did you process this? Did you process this? And then give us an error back. So the simple example, so we have this demo example in TXS, which is it just does this. It's called it just does a very simple script it signs a very simple script, and which just doesn't do anything on the blockchain, doesn't commit any state. It just prints something out in the move VM interpreter. Move VM. So what I would say here is we've got a bunch of things. So this is getting messy. There's a lot of new stuff in here that you haven't seen. But wait, to answer your question, this is how you normally import stuff. And so how do I tie this into something that Misko was asking? Okay. See, the one thing I'm importing in here from another project, so another rate here in DM is the DM transaction builder, which is effectively an SDK-like thing to give me transactions. They help me format transactions for signing and then sending to the blockchain. So I could, wait, to answer your question, I could just actually see where I'm using, I'm doing a few things here with this import, and you've seen this you guys in Python and JavaScript. I'm taking this entire I've got this DM transaction builder in my root. I want this library in that crate, stdlib, but I want to rename it. I want to call it transaction builder. If I go down here into, where am I using it actually? Okay, here we are. This is where I'm formatting a transaction. So I had renamed it up above as transaction builder in code. So this is the name of the script I'm trying to encode demo E2E script function. Another alternative way I could have written this is I could have just taken this here and just called it directly from the root. I don't necessarily have to name that import here. Everything that's in the root, and sorry, to correct what I had said before, it doesn't have to be in main. Anything, you can just call things directly from the root without actually importing them. So let's see, whoops, it's called TXS. Whoops. OL, sorry. So I'm just gonna, here's another important thing to know with cargo. If you don't want to run something or it's something that can't be run, it's just a library, you do cargo check, which will check if this will compile. Oh God, this is gonna take a while because I'm starting from a clean workspace, but usually faster. But this will compile, wait, to answer your question. I don't actually have to import something that's, I could just call it as it's named directly from the root. But that gets unwieldy, right? So
yeah, that makes a lot of sense. It's more for readability and making sure you know which is in each module, like which is in. Yeah, it makes a lot of sense. Cool.
Good. Yeah. Good. That's a better way to put it. Yeah. It's mostly good. So I'll stop here again, folks. We actually are covering a lot of ground here with a lot of Rust intro stuff. Where are we at? I mean, there's a lot of stuff going on here, so there aren't any silly questions, and you can see like this is not my, there's a lot of stuff that there isn't an obvious way to explain.
Maybe we could touch some issue that we could like small thing, what could like be like the actual work that we will do in the future, or like I don't know, like do we have some kind of task list like refactor something in this tool, or make sure it works in this way. It's not like actual like smaller example, not smaller example, but like how it would look like, so we'll know what we are, what to expect in a sense.
Yeah, good. So again, what I want to do is have they're going to be like different. People are going to. I want there to be something for everyone here. So even if you're just going into a file like this one, I think this is the baseline for what I think everybody should do. Let's say for next week. Let's say what everybody should do is you should get your environment set up so that you're able to go into any file here in the OL folder, stuff that OL has created, and take any one of these Rust files and make sure it's actually formatted correctly, for the Rust language. So Rust has a style guide, and you can change the style guide, but it's got a style guide that you can enforce with this Rust tool called Rust Format. So if I do Rust Format demos, TMD, does that work? Wait, am I in the wrong place? Rust T, what do I want to do? I'm in command, so let's stay at the top level here. Let's find something epoch. I'm wondering if this is formatted correctly, and the way I can do that is with Rust Format, and it actually did apply some changes to it. And you can see, just from my git diff over here, Rust Format wrapped some things differently to make it more readable and removed this and added this new line at the end of it. So there's a bunch of stuff in here that, there's an easy way. I could just run one command and it will format everything. But it's better to have a human look at, the formatting at the end of it to see if the Rust format worked. So I think that would be an easy first task for everyone. This will confirm that your environment's working, you're able to navigate through stuff. So just pick a folder in any one of the Rust code that OL is contributing. So types, TXS, tower, onboard, keys, skip Genesis tools, but CLI, and just do Rust format in some of the folders and see what it changed and see if it looks right to you. I mean, again, I'm not a style guide Nazi. It just has to be very readable for folks. So I would say that. I mean, how does everybody feel about that? I mean, it's maybe too easy for folks, but given that it takes time to set up your environment, I think that might be
I think that would be a good start when we go through all the modules and let's say OL tools. When we go through the code, read it, nevertheless, maybe we can understand it, maybe we don't understand thoroughly what it does, but it will bring the questions and it will be easier for the next session where we can ask those questions. We will know what to ask, basically.
Yeah, that's right. I think it's I like how you say it. I think this will just confirm that everybody's on the same page and that their Rust is working and things are compiling. And it'll give you it'll let your eyes start getting familiar with the Rust code. So I think that's the first thing, but your question was what to expect, what are the kinds of things that we would like to do? The CLI module we have here, there's an opportunity to split things up into smaller files, so to do some refactoring to clean up. So let's see if I can find the right one. I think this file here, node, look, this here has got 400 lines to it, and it's just very hard to follow everything that's going on in here, but this basically creates this object that has a bunch of information in it. So, and I think there's an opportunity to break out some of these tools into some of these functions into different files and clean them up. So I think that's one thing, okay, this thing is way too big. How would I split this up into files? Don't necessarily need to change the function signatures, don't need to change the arguments or anything, but just make this file more manageable. And that's gonna help us a lot. So I think that's the first thing from that's sort of the baseline of what our team here should be doing, our tool scrubbers. Let's make these things more readable, because we had to write these things very quickly and they're not really, they're a bit unwieldy. So that's the first thing. The next thing I'll suggest, and this will be a more advanced thing, and we'll talk about this next week or the week after. We'll talk about an important language design of Rust, which is the borrow checker, which is the borrowing of memory instead of creating a new memory by default. So that's what, and then these ampersands here are going to make a lot more sense to you. We'll talk about that. But basically, there's a lot of opportunities in everything that I've written, everything that we've written here, to borrow memory correctly rather than creating new memory. Because that's an anti-pattern in Rust. copy, to clone here, what I've done here, to clone a new object here. This is an anti-patterning. And there's some places where it just gets, but then to be able to do things correctly in Rust so that you're borrowing memory everywhere you need it to be borrowed, you end up needing to refactor things downstream. And sometimes we're just like too much in a rush, you know, performance doesn't really matter here. There isn't a lot of risk here. Okay, just put a clone on it and let's move on. I don't want to have to re-architect everything. So I think this is one of the important things that the tool scrubbers are going to be able to offer is like, well, when we go through and like actually do things in the correct Rust pattern, borrowing wherever we can, we actually make safer programs from a security vulnerability perspective. We're actually doing the things that Rust is designed for. We're making safer tools. And we're making them more performant as well. So I think that's going to be like a really great thing that, you know, really in just a couple of weeks from today, all of you guys are going to be able to do that. It's going to be really helpful. Did that give you some visibility? For that? Okay.
Yep, totally.
Awesome. So we might break now. I know we're over time here for folks, but any last questions? And of course, I can answer in the threads here.
I just want to thank you, Ade. It's really informative and it's a good starting point. Pretty excited about this.
Yeah, I'm super excited to have you guys contribute in whatever capacity that is. I mean, if you guys just want to show up and listen, so we'll do this every week at the same time. If you guys just want to listen, come in every week and listen. That's great. You're participating, part of it. You get the merits, you get the rewards. You know, let's try and make this I'll be here every week at this time, and if you guys, you know, start getting interested in Rust, start helping scrubbing tools, this really helps move the project forward because it's just going to make us feel a lot more confident in our own tools. And then for you guys, from just a career perspective, Rust is a super important tool for blockchain. Right? Everything's now, all the best of class projects are written in Rust, and you know, this is the way to get to doing protocol critical changes. So like in a month from now, you know, I could see several or even all of you being able to make consensus critical changes that are critical to consensus in certain modules. It's going to require learning a bit more architectural stuff, but in terms of the Rust skills you'll have, I can see in a month's time you guys will be, you know, the rest of the consensus critical stuff.
Yeah, and this time really nicely works with European time zones. So I'm UTC +2. It's evening after my day-to-day job, and yeah, so it works real well.
Super. All right, folks. Well, I'll answer questions in the threads then. Sorry, Philip, did you want to say something?
Yeah, I just have some rapid-fire questions. How do you debug things? So is VS Code also well integrated with a debugger?
Yes, good question, and I'm glad it shows you know what you're doing to ask the question. Yes, there's a good debugger. You need to install something here. It is the code LLDB. Oops, that thing. And you'll then, and we have some ready-made, you know, this is advanced stuff for other people, so if you're not listening, it's okay. In our repo here, we added this VS Code OL template with this thing called the launch JSON.
Yeah.
And these are sort of if you've done VS Code stuff before, these are sort of the different things, parameters that you do to test an individual CLI function in your tool. So
but yeah, and is this setup automatically created? Because for Python, I think it is created automatically when I set up just the Python
yeah.
debugger. Yeah.
Let me do this very quickly. Should I just show you how it's done? Oh well, this is the MGMT tool. MGMT command. So if I just drop in a debug a breakpoint, I should be able to. It's not turning up here, but I'll double check it. I've done something to my environment here, but in the drop down list you should have all of the. Oh, sorry, because that was a template. So in your own section, when you apply your template here, this is my launch template. So what did I do last team? Onboard val. Okay, so onboard tool. Val, and then so I'm gonna drop a breakpoint in here. And then if I just run that, it'll do the debugger will run for you. So for other folks listening, if this is way over your head, the debug stuff, don't worry about it. But like, this is a very powerful tool once you get into using breakpoints.
Yeah. Okay, and so most of the code can be executed by the debugger. So you need no or more dependencies, some integration stuff, or some databases, or
no. You just need the LLVM interface that I showed you before.
Okay. And then I have also a question regarding this monorepo dependencies. So, am I right when I say that every time you change something on top level, so for example in this language folder there, you have to ensure that it works for all the other repositories because they are importing from this code directly. So there is no pip repository, for example, for Python, where you can upload, or it is one, actually, you downloaded the time repository or the time library, but not here. So you do not upload everything into this public library and download it from there. You are importing directly from the code.
Yeah, exactly here. So let me show you these dependencies for the TXS app. I've got a bunch of these here that this pulls from the package manager, all of these here, from the rates.io, from the Rust package repository. But then I've got a bunch of all these other stuff in here that I'm importing from this monorepo. It's just importing from the app.
Okay, so there is no real versioning, for example, when you create a new version of DM Wallet or DMDB, you have to ensure that everything fits together then in the end.
In the monorepo, yeah, that's right.
Yeah. Okay.
Let's, do you want to break out a time? Because those are good and advanced questions. Do you want to, I can answer them offline quickly.
Okay. That was interesting. Thank you for the introduction.
Cool, guys. Cool. So I just do need to go talk to someone for a second, but I'll be back in the threads in about 30 minutes.
Cool, thanks, Eddie.
Right, thank you, Odi.
Thanks, guys. Exciting.
Yeah,
See you next time.
thank you so much.